Hi guys, this is Dr. Gonzalez, and I told you I would try to put a regression assignment video together for you, so that is what I have done right here. I've also made some updates to the template. I did not change any of the questions or anything like that. I simply went in and added some headers because that is something that we are now required to do with making our materials accessible to all students as far as accessibility, accommodations, etc. So the first thing you'll need to do is to open up the template that's regression assignment, okay, and put your name at the top like I normally ask you to do. You also need to download sorry, I'm losing my train of thought here, the data set. So if you look in Canvas, you'll see under the regression assignment submission, it tells you to read the document, use Jamovi, generate the regression analysis, paste the outputs wherever it says to paste them, and then answer the questions and upload the document. The template is right here. In fact, I'm going to go ahead and change that right now so that it uses the proper template. Okay, so we're going to remove that link and you can download the regression assignment. And your data set is going to be here. Make sure I spelled it right. G-N-M-E-N-T. And we're going to save that. All right. So once you have those two things downloaded, read this introductory part of the assignment. It says a researcher is interested how daily screen time and class participation affect student scores on a standardized science test. And by daily screen time here, I was concerned with daily screen time on a science app. So data were collected from 60 students, and they looked at hours of screen time per day as predictor 1, class participation score as predictor 2, and then the science test score is the outcome. So basically we're looking to see if these two predictors by themselves would be significant to the science test score, okay? And then we're going to build a model with both of them and see if that model is significant. And in doing that, we will find out if class participation is significant alone, if screen time is significant alone, and then again, if putting them together increases the science, is correlated really or related to the class participation score, the science test score going up. So the researcher wants to know if screen time is negatively associated with the test scores and whether participation improves prediction when it's added to the model. So we're going to run a simple regression. I'm going to move this over real quick so you can see Jamovi as we go. So in Jamovi, I'm going to start over and open this from the beginning, so screen time and test scores, okay? And let me get rid of this. Don't want to save that. So when you open it up, you're going to see that you get your data set on the left-hand side with our scores for the science test, class participation, and screen time right there. Okay. And we're going to run a simple regression first using screen time and our score on the science test. So what you need to do is go to regression, and we're going to go to linear regression, okay? And we're going to move screen time over to our covariate, and science test score is the dependent variable. Because basically we're testing to see if that screen time is associated with the science test score. And you can see we're already getting some output over here on the left. But you need to go through and make sure you're including down here the things that are important for our model. Okay, so you've already moved the variables over. Go down here under, let's see, model fit, and make sure that you've got R squared checked. And that's going to come out right there. You also need to make sure that you're running an omnibus test. So we're going to go to model fit, check that R square, then we're going to go to model coefficients. You're going to check for omnibus test, and you're going to click standardized estimate. Now, you don't need to include estimate and confidence interval right here, because all that's going to do is add something down to the bottom that we don't really need at the moment. Okay, so we're going to leave this right here. You need to snip these results. All right. And you're going to go back over to your template, and you're going to double click right there and hit paste. And what's going to happen is it's going to put it in here, and it's going to be really big. So I suggest that you click on the result snip and drag this up some to where you can still read it, but it's not, you know, too small. You can make it fit like that, and then your questions can roll down. What you don't ever want to do with an inserted table like that is drag the sides, because it distorts your output. The best way to resize any sort of photograph or image or whatever is to click on the circle at the bottom, and then you can do that. Look, if I do this, I made it way too small, and your instructor, which is me, can't read it. So I would suggest pulling it down like that, and then just watching your questions down here. They're going to bump to the next page, and it's not a big deal. So the first thing that you want to do is check your R squared value, and what does it mean? And all you have to do is go up here and find your R squared. It's 0.174. And then you're going to explain to me what that means, right? Because it means something, and you interpret that as how much variance is explained by that score in that variable. So whatever the R squared is, you multiply that times 100, and it gives you a percentage. And so you're going to tell me the R squared is whatever, and then you're going to say this explains whatever percentage of the variance in science test scores from this variable, okay, or predictor variable. Question 2 asks you, is screen time a significant predictor? And it says, remember, the ANOVA table tells you the model's significance. Now, at this point in time, our model only has one predictor, okay? So be careful. You could easily roll up here, and you could look at your omnibus ANOVA test, and you see that this P is significant. So I know that screen time is a predictor, significant predicting variable here, but you really want to look at model coefficients because this omnibus ANOVA test is different from the model coefficient test. It's a t-score down here and it's an f-score up here because this was an ANOVA and this is a basic t-test. All right, so just because this is significant, you're not getting the answer that you need from that ANOVA table. You want to look at the model coefficient table, and you want to tell me, it says, is screen time a significant predictor? And you want to tell me if screen time is a significant predictor based on the model coefficients down here. And I also want you to tell me how you know that, right? So if I go back up here, I can see screen time. I would say T is negative 3.50, and that is significant at a p-value of less than 0.001. So you would write that down there. Tell me where you got it and what it is and why it's important. Pretty simple so far, right? You're going to have to scroll a little bit because, like I said, when you paste that in there, it's going to bump down your questions. That's okay. Just to keep it nice and simple, just go to the next part right here. Now it wants us to add class participation to the model. So all you have to do is go in here and hit class participation and move it to covariance. You don't have to recalculate a second thing. All you do is add that and it actually updates everything you need over here. So you're then going to, I wonder what happens if we export it. Oh, it does it as a PDF. No, we don't want that. Some people, I think, have been copying this, and I don't know if it looks right when you put it in here, so we're going to try it. If I paste it as text, it comes out weird. If I paste it as a list, it comes out all right. And then if I paste it as, it looks okay too. Well, I'm going to go with the second one this time. All right, so the first question that it is asking is, what is the new R squared? Which, remember, that's telling me how much variance is explained by the two predictors in the model. So you're going to go up here and you're going to look at your R squared. Your R squared this time is 0.67. I'm not going to tell you. And you're going to tell me what that means. Remember, when you tell me what it means, you're actually telling me how much variance is predicted by both of those factors this time in the model. And it's pretty neat. In 6, it says, this class predicts participation a significant predictor, and how do you know? Remember, to find out if it's a significant predictor, look at the coefficients table, look at class participation. There is your t-score right there, and it is significant. I'm not going to go into detail because I want you to go in there and tell me that. You're going to type your answer there. Then you're going to evaluate if the model improved, and you're going to explain this by using R squared and p-values. So what you need to do is go in here to the first R square, which was in the top here. That was 0.174, and you're going to compare that to the second one, 0.639. Whichever one is bigger is going to tell me which model was better. All right, so remember, your first model only used screen time, and the second model is using both. The next question asks you, you're also going to compare it with the p-values. The p-values you're going to get from the ANOVA tables. So if you go back up to the first one and you look at the ANOVA table here, it says our model is significant. If you look at the one down here, it also says this model is significant. So you're going to have to interpret that. Part C is a conclusion, and it asks you which predictor appears to be more important. Support your answer with standardized coefficients. This is the standardized estimate. And you find that right down here, standardized estimate. So you've got two values, one for screen time, and it's a negative value. And then you have one for class participation score, and that is a positive value. So the standard estimate with screen time, because it's negative, it's telling me it has a negative contribution to the science test scores. So the more screen time they do per day, the lower their score is. I could get into the details behind that, but it would be a lot more than you need to know at this point in time. If you look at class participation, you see your standard estimate is positive. So to be able to compare them adequately down here in this question, you need to get the absolute value. And all you do with that is take that negative away. All right. And then if you look at these two, you're going to compare 0.464 and 0.683 and tell me which one's bigger. The bigger one is going to be the one that contributes more. Okay. And then 7, you're going to say, does the model fit improve? Explain using R-squared and p-values. So what you're going to do is go up there and look at the old R-square and the new R-square and tell me if there's an increase. Remember, Model 1 only used screen time. Model 2 used both variables. There's a difference between the two. Did it improve the model? Okay. Then for p-values, you're just going to look at the models, the ANOVAs for the first and the second ANOVAs here, and looking at the model itself. Did it improve? Okay. So look at those p-values right there and tell me if it improved. And then based on your results, actually on that one, you're going to, standardized estimate right there. Based on your results, what advice would you give to a student? Now remember, this right here, that negative standardized, standardized estimates, that beta that we look at in comparisons, the larger standardized coefficient is going to be the one that contributes more. Okay, so be careful when you're looking at that. And then based on your advice, what should you do? Well, what you're going to find out is that one of these variables is reducing screen time. One of these variables is in the model, it reduces the science score test. It's associated with a reduction. And then the other one is going to be associated with an increase. So basically, you're going to tell me what you would tell the student based on those predictor variables that you looked at. So when you're done with this, obviously, you're going to save it. And I would recommend that you save your assignments as a PDF. And I know I probably should have talked to you guys about this beforehand at the beginning of the semester, but it didn't occur to me till now. But in case you want to do that, because what happens is it often messes up the format of the template, and that's going to be important when you get to your paper, because the paper is graded with those APA things in mind, and you don't want the format to get messed up. So what you do to save this as a PDF is you go to File and Save As, and you're going to pick a place to save it. Okay, desktop, and then you go down here, instead of Word document, you tell it you want a PDF. And then I always have to go under options and check that everything is okay, because we've got to make our PDAs ADA compliant, but you don't have to do that part, but you just hit save, and it's going to save your submission as a PDF. I'm trying to pull it over and it won't go. So then you can just upload that and you'll be done. So if you have any questions, please reach out to me. And again, I've told you guys that ChatGPT can be a great resource for this because I can basically tell it to go in and tell me the steps that I would need to do to run this analysis. Now, please don't upload this document and tell ChatGPT to do it for you because your output is going to be different, and I am specifically looking for output that's Jamovi output. I can tell when this is not Jamovi, okay? So if you have any questions, please let me know, and I will be happy to get with you and try to help you. So take care and reach out if you need anything, guys. Bye.